Welcome to Lecture 8.1, Introduction to Object-Oriented Programming for Introduction to Programming in Mechanical Engineering. By the end of this lecture video, you will have an understanding of what the philosophy of object-oriented programming actually is, what classes are, how to define a class, how to define objects from that class, and what objects actually are compared to classes and how they differ from each other. This slide, the table of contents, contains hyperlinks to each of the sections to make the downloaded PDF easy to navigate. So far in this course, we've been practicing functional programming, which is where each piece of code is written to accomplish a specific task. This lecture introduces object-oriented programming, which is where we focus on representing the data in our systems and then define the functions that operate on that data. The notable difference between the two is that object-oriented programming, or OOP, restricts functions to operating only on the data to which they are tied. We accomplish this structure by defining classes. The class is the blueprint for how an object of that type is structured. The class definition organizes properties and methods to enforce rules about which functions can access which data. Let's illustrate this next with an example of material elongation due to axial loading. First, we use the class def and end keywords to set up the class definition, and we name the class MaterialSample. Then within that class, use the properties and end keywords to define the properties that the class uses. In this case, we'll store E for the Young's modulus, then A for the cross-sectional area, and L for the sample's length. Then we can use the methods and end keywords to define the functions of the class. The first one is called the class constructor, which provides instructions for how an object of this type should be instantiated. In this example, our constructor accepts 3 arguments, one for each of the properties. The constructor first sets the property E equal to the argument passed in. Note that dot notation here is used to set the object's value E equal to the parameter. Then it does the same for the property A and the same for the property L. Then the second function is one to apply axial loading to the material sample, which in its definition takes the object itself as an argument as well as P to represent an applied load. Passing the object itself using the obj keyword is necessary to ensure that the function is able to access and change the properties of the object, which will be necessary for this function because the object's length will change. Then inside, we apply the deformation equation from statics 1, where the object's new length is equal to the original length plus the force times the original length divided by the Young's modulus and the area, or PL over EA. Now, the first step of using a class is to instantiate an object of that class. In this case, we'll use 316 stainless steel, so we use the constructor and we pass in the Young's modulus, which I found online to be 193 gigapascals, followed by an arbitrary cross-sectional area of 2 centimeters squared and an initial length of 1 meter. Again, this line of code is using the class's constructor to set values for the properties of the object E, A, and L. Then we can apply the axial loading function with a force of 1 e to the 6 newtons, or 1 meganewton. This line of code applies a force to the sample, which in turn results in deformation, changing the value of L. So the last step is to print the object's new length by accessing the property. Using dot notation here, the line accesses the value of the property and prints it out. We see that the sample deformed by 1.3 centimeters and that its new length is 1.013 meters. To close this lecture out, let's quickly discuss the difference between classes and objects, because many people conflate the two with each other. A class is a set of instructions. It's the recipe inside of the cookbook. An object is the manifestation of those instructions. It's the actual meatloaf dish on the kitchen counter. You can't eat the cookbook recipe, but you can eat the meatloaf dish. The properties of meatloaf are defined by the recipe, but you can't actually do anything to it until you make the real thing. In summary, this lecture covered the philosophy of object-oriented programming, which is that it is an approach to programming that wraps up data and the functions that operate on that data in one big unit in order to create a very intentional usage structure for a code base. Classes are the blueprint for how attributes, the data, and the methods or the functions are wrapped up together. Now, defining a class is done by the class def keyword followed by the class name, and then the names of all of its properties are listed out with the respective keyword followed by all of the methods, again with the keyword, which can only operate on those listed properties. The first method should always be a constructor, which specifies the procedure for how an object of that class is actually brought into existence. And then defining objects from that class is as easy as declaring a variable equal to the class name according to the constructor. That creates an instance of that class or an object. Then you can apply any of the associated methods using dot notation as we showed before. And the difference between the two of objects and classes is that classes are the blueprint, while an object is the actual instance in code that exists according to the way that the class is structured.